Good morning to everyone. Today we are going to see about the transformer. So here a transformer is a device used in the power transmission of electric energy. The transmission of the current is alternative current. It is commonly used to rise or decrease the supply voltage without a change in the frequency of alternative current between the circuits. So transformers works on the basic principles of electromagnetic induction and mutual inductance. So it is the single phase voltage transformer. The input here we are having Vp, then you are going to get the output as Bs. So in this transformer we are considering the input as primary circuit, then the output as secondary. So here we are having three things. One is called as primary circuit, second one is called as the transformer, and the third one is called as the secondary circuit. So here the number of turn is NP in the primary circuit. Then the secondary circuits we are having number of turns which is equal to NS. The voltage applied to the primary circuit which is called as Vp, then the current flowing through the particular primary circuit which is called as Ip. And also here we are having the secondary circuit. The output of the secondary circuit is Bs, then the current flows through the particular Vs is Is. Here there is no direct electric connection between the two coils which is called as the isolation transformer. The principles of operation. So here we are having the primary coil which has 1000 number of turns. In a secondary coil you are having 100 turns. The input given to the primary coil is 200 volt. Here you are having the RMS value, that is here you are having the value of RMS. Then the current is I1, here the current will be I2. Here the voltage you are going to get the value of 200 volt at the secondary coil, because here the number of turns is 100. So here the changing the magnetic flux which will causes by the primary coil, it is based upon the principles of mutual inductance, according to which an electromagnetic field is induced in a coil when the current in the neighboring coil will changes. The working of the transformer. Here you are having the primary which will indicate P. This is the soft iron laminated core. Then this is called as the secondary coil S. When the current in the primary coil changes, being alternating in the nature, a change in the magnetic field is produced. This change in the magnetic field gets associated with the secondary through the soft iron core. Hence the magnetic flux linkage with the secondary coil will changes, which will induces the electromagnetic flux in the secondary winding. So here we are having three types of transformer: step up transformer, step down transformer, and impedance transformer. Based upon the voltage with respect to the input and output, these three transformers are formed. So here the step up transformer, V2 is greater than V1 means, that is voltage applied at the input is very much low when compared with the output means, here this transformer is called as the step up transformer. For example, we are providing the voltage V1 which is equal to 200, then in output outside we are going to get the output as 2000 volt, that is called as the step up transformer. In step down transformer, V1 is greater than V2. That means V1 we are applying large number of voltage like 2000, then we are going to get the output side as 200 volt. Then the third one is called as the impedance transformer. Impedance means the input side voltage, that is primary voltage V1 which is equal to secondary voltage V2. So here we have a turn ratio, Np divided by Ns is equal to Vp by Vs is equal to N. Here the turn ratio value indicates the operation of the transformer and the corresponding voltage available on the secondary winding. So this is the step up transformer. So here the input alternative current is provided to the voltage source. Here this is the primary winding, this is the secondary winding. We are comparing this primary with secondary winding. This is very much low when small amount of winding when comparing with the secondary winding. Here the number of turns is 3000, the voltage is equal to 25 volt, but we are going to get it in output side. Voltage is equal to 50 volt, then the number of turns is equal to 6000. This is the core of the core part of the transformer. So for economic reasons, the alternative current power is transmitted at a very high voltages, 220 to 440 over long distance. Therefore, a step-up transformer is applied at the generating station. Then the next is a step-down transformer. So here the step-down transformer number of turns is equal to 120, input voltage equal to 480. Here in turn with respect to the primary, here the winding will be very low when compared with this primary winding. So the number of turns is very much less, here 30. Then the voltage we are going to get it at the secondary side, which is equal to 120. For feeding different areas, the voltages are stepped down with respect to 440 to 230 for the safety reasons. Then the isolation transformer, primary which is called as the input and secondary is called as the output. This is we are having the separate windings for each other. The input power and the output power are electrically separated by the dielectric insulation barrier. So this is called as the dielectric insulation barrier. This is the input side, this is the output side. This is called as the isolation transformer. The next one is called as the auto transformer. So here the primary and secondary which will sharing the common winding. So here we are having the secondary voltage which is always common terminal with respect to the primary. So here we are having the secondary part, this one is we are having the primary part. This transformer is called as the step down transformer. When the secondary windings is very much less when compared with the primary, this is called as the step down. Then here we are having the primary which is less with the secondary when compared with the secondary. Here we have step up auto transformer.